So this next unit is a unit all about energy. So this first video that I'm doing is going to be kind of an introduction to some different types of energy that you may see within this particular unit. So mechanical energy is, that should M-A-T-T-E-R, that's matter, M-A-T-T-E-R, and that is matter in motion. Okay, so if we have something moving, if it is moving, we say it has mechanical energy. Heat energy is the transfer of thermal energy between molecules within a system, and it is measured in joules. And we're going to talk more about thermal energy and what this is a little bit later on in this unit. Chemical energy, this is the energy existing in the bonds which are going to hold atoms together. And if you'll remember from our chemistry section of physical science, we spent a whole unit talking about chemical energy. And we learned that when bonds are broken, energy is released. And when bonds are created, energy is stored within those chemicals or compounds. Another example, if we wanted to relate this back to biology, think back to biology, all right, and how does your body get energy? Your body stores energy as adenosine triphosphate, ATP, and when it breaks a phosphate off to make adenosine diphosphate, ADP, energy is released. So breaking this phosphate off releases energy. The electromagnetic spectrum is the moving of electrical charges, such as electricity, and it is caused by the movement of electrons. This is also how different waves form. And if you'll remember back in chemistry, we did look at the electromagnetic spectrum, and here it is on your reference tables. Okay, and we have a bunch of different types of waves, our radio, our microwave, infrared, our visible light, the colors we see, UV, X-rays, and gamma rays. So we've already looked at this a little bit. We're going to look at it in even more depth in our physics unit of physical science. All right, nuclear, this is energy that is held within the nucleus of an atom, and this again is a review from chemistry. So let's look at the two types of nuclear decay that we talked about in chemistry. We have fission. Fission is when the nucleus splits apart. So the nucleus of an atom splits apart. Energy is released, and it is released in the form of heat and light. Then we also learned about fusion. Fusion is the opposite of fission, and to fuse means to bring together and to put together. So fusion is taking nucleus of atoms, two atoms, and putting them together, fusing them to create a single new atom. And we learned that the sun's energy and stars are an example of fusion, and this energy from the sun that comes down here on Earth, it heats the Earth, is caused when hydrogen fused together to create helium. All right, so let's look at energy. We've talked about the law of conservation of mass. How can we take that same concept and look at it in terms of energy? So now instead of conserving mass, we're conserving energy. Okay, so energy is not created or destroyed. It simply rearranges. So it goes from one form to another form, and all forms of energy can be converted into other forms. For example, if you turn on a light bulb in your home and then you go and touch it, don't do this, okay, because you might burn yourself. But if you were to touch it after it had been on for a while, you would notice it was hot. Don't do that though, because you may burn yourself. But while you turn the light switch on, you can see that it does have light. Okay, so the light bulb is taking electrical energy, all right, because you have to have electricity in order for that light bulb to work, and it is converting it into light and into heat. So let's look at these pictures that I have for us, and let's do some examples. So when you eat something, the food that you eat is chemical energy. And then maybe you get on your bicycle and you're going to ride your bicycle over to a friend's house. All right. Motion, the movement is mechanical energy. So your body uses the food that you eat to pedal the bicycle. All right. So you moving your feet and pedaling that bike is your mechanical. So what I'd like for you to do is I'd like for you to pause this video and I'd like for you to attempt these 3 practice pictures. Okay, so let's look here. Here we have a gas pump. All right, gas is made up of chemical. It is a chemical. And when we put gas in our car and then we push the accelerator down, our car starts to move, so that is mechanical. Now, if you've ever popped the hood of a car after it's been moving for a little while, you may notice some heat is coming out. All right, so it does also produce thermal energy or heat energy as well. All right, now don't actually do that and touch anything, because again, you may burn yourself, but the process of the engine and motor and all of that working does produce heat. All right, so the sun, we've talked about, that is fusion, which is nuclear. And the trees and all of our plant life, what they do is, we learned in biology, through the process of photosynthesis, they use sunlight to create glucose. And glucose is a compound, so it is a chemical, and that's the food that plants use. All right, so here we have a stove. Now, it depends on if your stove is electrical or not. This stove is electrical. We can see here that it has the electrical outlet, or not outlet, but the electrical plug. Your stove at home may be a gas stove, but in my example, it is an electrical. And now our stove does produce heat in order to cook things, so that electrical is being converted into thermal. All right, so how does energy transfer through a system? We have conduction, and this is the movement of heat energy through a system. For example, if I put a metal rod in a fire, the handle of that metal rod eventually becomes too hot to hold. So we have a movement of heat through that substance, and in this case, it's the metal rod. So the heat's moving from the tip of the metal rod in the fire all the way up. And this is why things that we have for grills and for fire pits and stuff, the handle itself is some sort of other substance. That way we don't burn ourselves, because that heat will move through the metal. Convection. This is a transfer of heat energy through a liquid or a gas. So if it involves a liquid or a gas, and now remember, the air around us is a gas. All right, so this is going to be the movement from warmer to cooler, and you may remember this from Earth Science. You have an entire unit on clouds and convection and how different weather patterns change and whatnot. Okay, so the movement of heat energy from warm to cool. And this is why the second floor of a house tends to be warmer than the first floor, because that warmer air will rise to the second floor. And finally, we have radiation, and this is going to be energy in the form of rays and waves. And this is going to be, again, our electromagnetic spectrum. All right, and we're going to look at this in more detail later on in this physics portion of the class. So here we go. Has this ever happened to you? Let's do this. Think about it. Your mother yells at you on a cold winter day and tells you to close the door. You are letting all the cold air inside. My mom used to do that to me when I was in high school, and she used to yell at me all the time to close the door. All right, I was letting the cold air inside. So is she correct? Explain. I'd like you to pause this video, try it out, and then check your answer. All right, no, she is not correct. Why? Because convection is the movement of a gas, that would be the air, from warm to cool. So the cool air is not moving inside. The warm air is going outside. All right, so heat is being transferred by convection. From warm to cool. You are not letting the cold air in, but instead the warm air out. Great, and as that warm air travels outside, it gives you the sensation of a coolness. That's why it appears as if the cold air is coming in, but it is in fact the warm air going out.